Hey everyone, welcome back to cracking the GRE math subject test. Before we get started, I just want to remind you to subscribe to the channel if you like these videos. It'll help me make more of them, and also leave a comment if you like the background color and font colors. I'm trying out different colors here, so let me know what you like best. Alright, here we go. This problem is from the differential equations chapter, and what we have to realize here is that this is a linear homogeneous equation. That means that it's a linear combination of y and its derivatives, and that linear combination is equal to 0. So what we're going to do is we're going to use the general solution for a linear differential equation, and then we're going to use these initial conditions to solve for the constants. Okay, so whenever you're solving a linear differential equation, first you have to write out the auxiliary equation. What's the auxiliary equation? It's a polynomial with the same coefficients as your linear differential equation, but instead of the y's and y primes, you have some variable like m with the same number of exponents as the derivative, the order of the derivative in the original equation. So for example here, our auxiliary equation would be m cubed minus a m squared plus a squared m minus a cubed all equal to 0. Now we have to solve this auxiliary equation for m, and that will help us write the solution, the general solution. Now the trick here is to realize that if you factor out an m squared from these first two terms and an a squared from these last two terms, then you'll have m minus a left over in each of them, and you can factor that out. So let's do that. You got m squared times m minus a plus a squared times m minus a all equal to 0. And if we factor out m minus a, we'll get m squared plus a squared equal to 0. So we're going to have three roots to this equation. The first one is m equals a, and then here we've got two imaginary roots that are conjugates of each other, because m squared equals negative a squared. So if you take the square root of both sides, you'll get m equals plus or minus I times a. So when you've got a real root, then the general solution is y equals c1 e to the ax, where a is that real root. If that real root had multiplicity 2, let's say, then it'll be c1x e to the ax plus c2x e to the ax. And if we had two real roots, then it would be c1 e to the ax plus c2 e to the bx. But in this case, we just have one real root. And then the second part is, what do we do with these complex roots? Well, when you have complex roots, then you're going to have a c2 cosine of ax plus c3 sine ax. And that's what you do with the complex roots. Since they're always conjugates of each other, then you just have to take that a and put it in there. Now we have to figure out what c1, c2, and c3 are. Alright, well, let's see. That's y. Let's write out what y prime and y double prime are. So y prime is going to be a c1 e to the ax minus a c2 sine ax plus a c3 cosine ax. Alright, and then y double prime, let's make a little border here. Y double prime is going to be the derivative of that. Well, what's that? That's going to be a squared c1 e to the ax minus a squared c2 cosine ax plus a squared c3, sorry, that's going to be minus a squared c3 sine ax. Alright, that's the second derivative. And then we can use the initial conditions to figure out what C1, C2, and C3 are. So let's see, f of 0 equals 1. Well, what's f of 0? Well, we know, so then we get, let's see, 1 is equal to C1 e to the 0. E to the 0 is 1, so that's just going to be C1 plus C2 cosine of 0. Well, cosine of 0 is also 1, so that's going to be plus C2 plus C3 sine of 0. Sine of 0 is just 0, so that cancels, that falls out. So we get C1 plus C2 equals 1. Let's try the next one. F prime of 0 equals 0. So we get 0 is equal to, here's our F prime. So we get a C1 e to the 0. E to the 0 is 1, so we get a C1 minus a C2 sine of 0, 0. And then plus a C3 cosine of 0. Cosine of 0 is 1, so that gives us plus a C3. And our final initial condition is f of 0 equals a squared. So let's give that a shot. We'll get a squared equals, now we're going to use this equation. A squared is equal to, let's see, a squared c1 e to the 0. E to the 0 is 1, so that just gives us a squared c1 minus a squared c2 cosine of 0. Cosine of 0 is 1, so that's just going to be minus a squared c2. And then the sign term drops out because sine of 0 is 0. So these are our three equations that we need to solve. So let's see what we can do with this. Well, we know that a is not 0 because it tells us that a is a positive constant. That's the first sentence in the problem. So we can rewrite this equation as c1 plus c3 equals 0. Just divide everything by a. And same thing goes here. We can divide everything by a squared. In the third equation, we get 1 equals c1 minus c2. So let's rewrite that. We get c1 plus c2 equals 1. c1 plus c3 equals 0. And c1 minus c2 equals 1. Well, if we add the first equation and the third equation, then the c2 cancels out, and we get that c1 to c1 equals 2, which means that c1 equals 1. Well, if c1 equals 1, then c2 has to equal 0. And c3 has to equal negative 1. Alright, so we got our constants. So now we can write the equation. Y is equal to e to the ax plus 0 cosine ax, so that just drops out, plus negative 1, so that's minus sine ax. Alright, well, that's our equation. Now, what's the problem actually asking us? It says that it's actually asking us how many positive values of x satisfy the equation f of x equals 0. Well, let's see. I'm going to scroll up here. F of x equals 0 would mean that y is 0. And then we get e to the ax minus sine ax. In other words, we want to know how many x's satisfy the equation e to the ax equals sine ax. Well, if you think about the graphs of e to the ax, well, it's something like this, where this is 1, because e to the 0 is 1. And sine ax, well, that's something like this. Sorry, it's actually something like this, okay, more or less, because sine is bounded, so it's never bigger than 1. That ax just changes the frequency. So we know that they can never cross. At least not... Yeah, no, they can't. Well, let's see, what does the question ask us for? Not when x is positive anyway, let's see. Yeah, and it asked us how many positive values of x satisfy that equation. So the answer is 0, because no positive values of x can possibly satisfy that equation, because whenever x is positive, these two graphs never cross.